Great. Good morning, everyone. Thank you for your patience as we are trying to get all our tech worked out here. Welcome, welcome, welcome to our special event this morning. My name is Julie Tomei, and I am an educator at the ROM. I will be leading this session. Before we start, just a few housekeeping things. We will be using the Q&A today. The format for the session is that Kim Tate and I will chat for a little bit, and then the last 10 minutes of our 30 minutes together, you'll have a chance to ask anything you want in the Q&A. To help us out to manage the Q&A, we have another ROM staff member, Sarah Elliott, joining us today. She's going to be making sure that the Q&A doesn't get too crazy so that I can pick out questions to ask him later in the broadcast. So I'll ask that you please use the Q&A only for asking questions. I know it's fun to say hi to everyone, but they're not going to be able to see it anyways because of the way we have it set up. Before we jump into our chat, I do want to do a land acknowledgement. So the Royal Ontario Museum acknowledges that the museum sits on the ancestral lands of what has been the ancestral lands of the Wendat, the Haudenosaunee Confederacy, and the Anishinaabe Nation, including the Mississaugas of the Credit First Nation, since time immemorial to today. Now that's the land where the museum sits. I'm joining you from home today, so I'm actually on the ancestral lands of the Chippewa of Lake Simcoe. Okay, so I think that's all the housekeeping that we have to do. So without further ado, Kim, can you please introduce yourself to our audience?
I'd be happy to. So my name is Dr. Kim Tate. I am the curator of mineralogy at the Royal Ontario Museum. So I take care of all the earth sciences collections. So I take care of minerals, meteorites, gemstones, and rocks. I'm a geologist by training, but I have been involved in a few space missions as of late. So I think we're going to talk about one of those today.
Absolutely. Okay, something just went weird on my computer. So I'm just going to do that and open that again. Sorry, everything went on the fritz.
It's Monday morning. That's what happens.
Yeah, you know, the computer's not feeling up to it either.
That's okay. So while you do that, Julie, I can probably just start talking about the mission. So on February 18th, which was almost a month ago, the Mars Perseverance rover landed on the surface of Mars. It was very successful, which is great news. And it landed in the basin of Jezero Crater, which is behind me here on my screen. So don't worry about pulling up images, Julie. That's not going to work. I have one behind me. Yeah, so what's really cool about Jezero Crater is that it appears to be an ancient lake. So this was where flowing water was on the surface of Mars at least, several billion years ago. So this was a really great place for the rover to land to learn about the history of Mars.
Excellent. So you must have been watching the landing. What was your experience of watching that?
Of course I was. So yeah, no, it was a really fun day. There was a lot of people that were really interested in finding out more about what was happening with the landing. So I did talk to a couple of news crews, and I did some radio, and I did some interviews throughout the day. But when it came to the landing, first of all, I had to get to Krispy Kreme because there was a Mars donut that was being offered only on that day. So I had to, it was kind of blizzardy out that day actually. So I was driving through all the snow, got some donuts, headed home, and watched it with my 5 kids. So it was a really fun experience with my family, but also I had another laptop with my work colleagues as well. So I was kind of experiencing it with my family, but also my work colleagues as everything sort of unfolded.
Amazing. Space donuts. So we have a photo here that I'll share. of people celebrating. Here we go. Some folks
Yay.
celebrating.
Technology is working, which is awesome. So yeah, these are people that were at the Jet Propulsion Laboratory that were celebrating the touchdown as well. That, this is a lot of really smart people that have come together to make this happen, both on the engineering side and technology and everything. This image is a little blurry, but what's really cool, and I just learned about this on this landing, is that it is customary to eat peanuts. So for the next landing, I hope everybody on here can grab a bag of peanuts and make sure that everything goes smoothly. It's a little bit of, this goes back to the 1960s when some of the landers weren't as successful, and the 7th time they tried, they handed out peanuts to kind of reduce the stress and the anxiety in the room, and everything went really well. So it's sort of a tradition to have a good snack as this is all unfolding.
Good luck, peanuts. I was watching with my my 8-year-old who's allergic to peanuts, and so their question was, "Mom, what if you're allergic?"
Don't eat peanuts then. That is what I recommend. Not safe at all. But you can have some other non-peanut snacks. I'm sure it would have the same good luck.
Yeah, your kids must have been super excited.
They were super excited. It's it's kind of hard to watch on a computer screen and stuff, but you can really feel the energy as you see these people here who are almost in tears, right? This is so exciting for everybody to land, but this is just really the first step in a series of missions to ultimately bring samples back from Mars. So although exciting, there is still a lot to come.
Oh, absolutely. So you spoke to us a little bit about Jezero Crater. So here's an image of what it may have looked like in the past. So what is it about Jezero Crater that made it so interesting to send a rover there?
So we as in humanity have sent, not just me, not just us on this call here, humanity has sent other rovers to the surface of Mars before. So this isn't the first time, but from all that information that we've gathered before, they've, the scientific community came together and tried to identify one of the best places to look for ancient life. And they felt that this crater here, Jezero Crater, has geological features that appear to be from flowing water. So if you can, I'll just scoot over a little bit, and you can see, this delta. So this is all the sediment material that is being dumped from the higher. Thank you. I can move back. So all the flowing water on the surface that has dumped into an ancient lake. All that sediment might be a really great place. That's where we would look for life on Earth. So if we're going to look for life on another planet, that's a great place to go.
Awesome. So clearly looking for signs of life on another planet as one of the goals of the Perseverance mission. Are there any other science goals that the mission has?
Well, just learning more about this planet is always exciting. So, I think of rocks, all the rocks that we find on Earth. If you go up to your cottage and pick up a rock, it's going to tell you a story, right? And really, as geologists, we are just taught on how to interpret those stories. So each of those rocks have a different color and have a different shape and have a different, something about it that is different than the other one. And I think of geologists as sort of rock detectives. We sort of are able to sort of tease out that information and tell us about planetary formation and kind of the bigger picture. And so any rocks that we can recover from another planet is just going to tell us more about what happened there in the past. And, Jezero Crater is billions of years old. And we know that Mars formed kind of around the same time as Earth. And, something dramatically happened that's different on Mars than on Earth. And I certainly would like to know what that difference is. Maybe that will foretell what could happen on our planet, right? So we need to understand these processes for sure.
Awesome. So there are, as you mentioned, going to be samples collected. What is special or might be special about the rocks that will be sampled?
Sure. So we do have rocks from Mars already on Earth. So these would be rocks that have been launched off the surface of Mars, have traveled through space and made it through our atmosphere and landed on the surface of Earth, which is super exciting. And we do have some of those at the ROM. So once we open up and it's safe, I do recommend that everybody come to the Tech Gallery, which is just above you in that picture, behind you, right up there, and come and have a look at them. But that is only sort of the most strongest rocks, basalts, so rocks from volcanoes that can make that journey. But the rocks that we're going to be collecting from Jezero Crater are going to be sediments. So these are going to be rocks that you would find more at the beach, not at the volcanoes. So these are just a different type of rock that we've never been able to recover from Mars before.
Awesome. And different kind of rock means different kind of information.
Exactly.
All right. So how will these samples be collected?
Very, very difficult process. So, well, the collecting isn't so hard. So on the rover, there is an arm of the rover and there's a drill on the end of that. And the drill is going to, basically the rover is going to go up the hill that we see behind me there. And it's going to drill out certain types of rocks. And there's going to be people that are on Earth that are going to be, deciding which are the most interesting rocks. And they're going to put them in sample tubes. So these tubes are, they're about the rock will be about the size of a piece of chalk, your pinky finger kind of size. And these rocks are going to be left on the surface of Mars for another launch that is going to happen later. And there's going to be a recovery rover. The rover is going to pick up all these sample tubes, and then it's going to launch it off the surface of Mars, and it's going to be captured in space and then brought back to Earth.
Awesome. So how will the sites be chosen?
Yeah, so there's a whole group of people that are working on this, the Mars 2020 mission scientists. So they get to, there's people that are operating the instruments that are on board Perseverance. So these are the eyes and, the hands. These are like the robotic geologists that are out there on the surface of Mars, sort of looking and analyzing and studying what's on the surface. But, really the ultimate goal here is to get these rocks back to Earth. So once those decisions are made on the samples, again, they're going to be cached. They're going to be left in spots for this little rover to go and get them and ultimately be brought back, which is super cool. So it's great to be able to do science on the surface, but it's even better to get these rocks back to Earth, because then we can take them to our laboratories and study them in different ways.
Absolutely. I imagine it would be very difficult to get the bottom floor of the ROM's equipment to Mars.
To Mars, yes. They're a little heavy,
Yeah. So here's something that I've been wondering. Given what we know about Mars weather and like global, dust storms, these tubes are pretty small. Why are they being left on the surface rather than being put back in their storage slots on the rover?
That's a good question. So as the rover goes along, if you can see those hills kind of above the top of my head there, it gets more and more dangerous. So the Perseverance rover is about the size of a Mini Cooper, so it's quite large. And what they've decided to do is to put them in safer spots so that the smaller kind of half a Mini Cooper sized rover can get to them. So it's just more of a safety issue, because we don't want to launch a rover, it gets there, and then it can't actually get up the hill to collect the rocks. So,
that makes sense.
So it's just to kind of leave them in safer spots. So the current plan is to have two caches, to have two spots where the rocks are left. So if plan A doesn't work, you always have a plan B. But this is going to change as they start roving around and finding cooler and cooler rocks. I wouldn't want to make those decisions, because just like as you go on a hike, the next rock is always the coolest, and then all of a sudden you don't have any more, backpack space, or pockets are all full. And I don't know if that happens to anybody else, so it happens to me. So yeah.
Oh, absolutely. I always have to tell my kids they have to choose one rock to bring with them, not 17.
Right. I used to bring the 20 home, so yeah, it made it moving hard for sure.
It's heavy. Okay, so you mentioned a rover is going to go down and collect them. So how will that be brought back to Earth?
Yeah, so I talked a little bit about the mechanisms of launching. We've never ever launched a rocket off another planet before, and again, we as humanity, not me and you, but I should be really clear when I say we, but so this is a really complicated diagram. I don't want people to stress on this too much, but what I do want to point out is that there's a series of missions. So again, Mars 2020, super exciting that it landed, everything was safe, but we're going to have this, sample retriever lander happening, and then this Earth return orbiter. So that's the one that's going to capture it in space, enclose it, keep it safe into, these secondary chambers, and then brought to Earth, hopefully shooting for 2031 at this point. So what's super exciting about that is that there's people watching right now that would be almost old enough to be studying these. So do really well in science and math, and ask those questions about rocks, and get you all trained up for those samples to come back real soon.
That's exciting. All right. So we get the samples back to Earth, then what?
So that's where I come in. So we've been meeting with a group of scientists from around the world every week already for years, and we will do so for the next decade, probably, getting prepared for these samples. So there is a small, but a chance that there is going to be some sort of, likely ancient life, extant life that doesn't exist anymore. But with that possibility, we have to keep planetary protection in mind. So we need to be not only protecting the samples that are coming back from Earth, we have to protect Earth from the samples. And I think that's more the important thing, is that we don't want to, if we do determine that there's life in these samples by studying them, we don't want it to be some sort of contamination that came from Earth, that, from sneezing on your hand or something like that. Like, we don't want to have that contamination. So these are going to be in the highest sample security facilities that haven't been, they're going to be built in the next little bit, and getting ready for all the procedures and all the storage and all the handling of this material. So that is what we're working on already. So super exciting.
That is exciting. So how did you become involved with this project?
Well, I wanted to be a geologist since I was probably 11, 12, kind of in that range. I just started picking up rocks and stuff in my pockets, and then coming home and trying to understand why they're a certain color or shape, or why some shiny one or some are not. And then I got to high school, and I loved science classes. And then I went to university and fell in love with geology again, when I could take it more formally and I got my PhD. So I did my lot of school, 10 years of postgraduate school, and then got a job at the ROM, which is super exciting. You get to look at all these rocks all day normally when we're back at the museum. Can't wait for that. But and I started, getting really excited about the Martian meteorites in the ROM's collection, and that brought me to start studying them more formally. And all my students and everybody, we just started studying Martian rocks, and that's kind of what they needed, is somebody that could not only study the rocks and understand them, but also take care of them and sort of the curation aspects of it. So I got picked to help out with this mission on the curation side. So right now I'm the co-lead of the curation focus group for the Mars Sample Return Program. And I'm just working away, trying to come up with all of the little nitty gritty details of, I couldn't even imagine. I'm like, you can't work on bringing samples back for 15 years. That's ridiculous. But then you get into it, and, oh yeah, yes, you can. There's a lot of things to work out. So that's what we're working on right now.
Yeah, these are certainly long-term projects.
Yes.
Keeps you busy, gives you a career.
I am not bored. There's no boredom whatsoever in my days, that's for sure.
So does that mean that some of this material will be stored at the ROM?
Well, we have to bring it back first to a sample receiving facility. And again, this is going to be a BSL, so biosafety level 4. This is where rocks, samples of COVID-19 and Ebola and all those types of materials are held. So that will be sort of the first step. And only way to get it out of that facility is to deem it safe for release, or sterilizing the material, and all those procedures. And we haven't done this before, right? Like, we've never brought samples back from Mars in this way. So it's going to be a lot of details being worked out right now, exactly what that means in getting them safe. But eventually, once they're safe and once it's totally safe to do so, I really hope they can't come back to the ROM and either show them or work on them and show the results to the world. That's really the ultimate goal here.
That would
My
be,
goal, at least. Yeah.
that would be like the coolest exhibit ever.
I think, maybe some people might want to come by and have a look at that for sure.
Yeah.
But for now, there are other Mars rocks. There are really super cool rocks that we can show and also have exciting stories too. So
That's true. Absolutely. Once we reopen, folks, if you can come visit us, go to the tech suite, and we've got a beautiful wall of meteorites, including meteorites from Mars that you can um, jump in and do. Sorry. All right. Sorry, a little late to turn on the live captioning. Thank you, Sarah, for that note. Okay, so this last thing is pretty cool. There are some chips on Perseverance with people's names on them, and I understand that your name is on Mars.
absolutely. So mine, as well as 10.9 million people's names, are on these 3 chips. And the chip actually says explore as one, which is super cool. But this, I actually signed up this morning. So all the people watching, go do this. You can actually get your name pull ready for the next launch, which is scheduled in 2026. So this is a future Mars mission boarding pass that is placed here. And I really recommend everybody going and do that. That's your homework. I find.
Fun and easy homework.
Mhm.
I'll take it. All right, so we have still a few minutes left. We're going to turn it over to questions from the audience.
There's a few.
The first one is, what kind of gravity does Mars have?
Not very good gravity, it turns out. So, comparatively to Earth, it's lower, certainly. So if you care about your weight, it's going to be a lot less on Mars. And the density of the atmosphere is much lower as well. It's only 1% of our atmosphere. So you have to, if you were to travel to Mars, and that is a goal of of humanity, is to get there, like Matt Damon, you would have to wear specialized suits to make sure that you're nice and safe, because the atmosphere is also very carbon dioxide rich. So it's very different than the surface of Earth.
Neat. Is there more water found on Mars, or just at the site that you mentioned?
Yeah, so the whole surface of Mars has geological features like the Delta system. We see other geological features that look like there was water on it. We have a lot of images now of the surface of Mars that we can study and look at. And there's even some polar water that is frozen on the North Pole of Mars too. So there's been lots of new advancements in the science and understanding of water throughout the solar system, not even just on Mars, but throughout the solar system. And there seems to be a lot of water out there. And where there's water, you usually, the whole NASA campaign is follow the water, because when you find water, you tend to find possibility of life, right? So that's one of the main ingredients.
Yeah, it's definitely exciting times. This was not something any of us knew about when I was in grade 6.
Not at all.
Why do we know? Do we know why there's no longer water on Mars?
Well, we have ideas, we have some thoughts, and that's what scientists do. Is you have a hypothesis, and hopefully your teachers are talking about that in science class. You have a possibility of why that is, and you then study different mechanisms of what has happened to either prove that's true or refute that. So science is constantly changing. Like Julie just mentioned, we didn't think there was water on any planet before when we were children, right? So this is something that is newer to the scientific community, and that's what gets me out of bed in the morning, is the excitement of trying to learn and understand more about different planets, because there's just so much more to learn. And that's what is exciting about science, I think, at least, is that if we knew everything, then we wouldn't have a job. But there's still so much more to explore and to learn. And each one of these missions sort of brings a new, whole new slew of information that we then can sort of alter our hypothesis or alter our thoughts and that's what I do is, besides working on the mission, is write papers in scientific journals to help understand what's happening. And we're learning new things all the time.
Yeah, so we don't know for sure. We have some ideas, and hopefully all these missions that we're doing will get us closer and closer to an answer. All right. One of our viewers would like to know, how big is Jezero crater?
It is 45 kilometers across.
That is a
So
big
it
crater.
is it's a big crater. It's a huge crater, which was kind of helpful for landing. They wanted to have, a nice safe spot for the Perseverance rover to land. So a lake bottom is probably a good spot. You don't want to land where there's too many boulders, or when the sky crane was dropping down the rover on the surface, it was actually calculating the safest spot for it to land, which is super interesting. And it landed literally right in the middle of the ellipse of where they wanted it to land. And that's just really showing how much the technology has improved on making these nice safe landings. But as it goes up the hill, as you can see, it's going to get more and more rocky, and it has some super great tires on the tread to make that journey.
Okay. We have a student who'd like to know, does it rain on Mars?
Does it rain on Mars? That's a great question. I don't think it does anymore. The atmosphere is very, very different than it is on Earth. When we look up in the sky, we can see clouds, and we can see, we have this really complex atmosphere above us. Mars has just a very weak atmosphere. It doesn't protect the surface, which probably is a better answer to one of my last questions there about why is there no more water, is that we just don't have the protective atmosphere that we do here on Earth. And as the sun beats down on the surface, and just all the radiation that is coming down on the surface of Mars, we don't have the processes that we do on Earth. But that would be super cool. Maybe it did at one point, but we don't totally know.
I imagine that it's probably likely that it did back when there was surface water, but hard to have rain without surface water, hey?
Right. Yeah, that whole water cycle thing is hard to do without the ground.
Without water.
Yeah.
All right. Let's see.
There's a few questions happening down there.
There are so many questions.
How do you pick?
I'm trying to pick the ones that are most relevant to your work on this mission.
Okay. I'm ready.
Okay. When will it start taking samples? Will it start taking samples like right away, or will it take more time to get to that?
Yeah, that's a good question too. So right now the rover is sort of getting acclimatized to its new environment. You think if you were on a 8-month journey to a new planet, you'd probably want to stretch your arms and legs, even if you just go for a short drive, right? You just kind of feel a little tight and tense. So right now it's going through all of its checks, making sure that the tires are working, etc. So it's not quite ready yet. There's a little helicopter that needs to get all prepared as well, which is maybe one of the cooler things about this launch. So definitely check out the helicopter if you haven't already. But yeah, so it's not going to be right away, but it's already starting to move around a little bit and get all ready for the time. And we're hoping sort of in the next year that a lot of, not a lot, but a few of the samples will be collected and ready to be picked up.
Excellent. Well, it's hard to believe we are at 11 o'clock. Kim, thank you so much for joining us today. It has been amazing having this chat, having you answer some of the student questions. Students, I'm sorry that we could not get to all 350 questions that you've asked us, but thank you so much for your curiosity and your questions. And we hope to see you at the museum again soon.
That would be great. I look forward to that for sure.
All right. Bye, everyone.
Bye.